Hello everyone, how are you? I wish you are good and good health. Today we will continue our science lessons, which is lesson 3 of chapter 6, which talk about weathering and erosion. In today's lesson, we will talk about weathering, which is the part 1 of our lesson. The second part will be after we finish weathering, we will take erosion and deposition. I hope you enjoy today's lesson. Please focus with me and to understand each part of our today's lesson. We will divide today's lesson into 3 parts as usual. The first part, I'd like to explain to you more about Earth and Earth's surface to be easy for you to understand today's lesson. So we're gonna warm up by some informations about the Earth's surface, then we will continue explanation our today's lesson, which is talk about weathering. We're gonna take weathering and know more about weathering and the kinds of weathering as well. So follow me, enjoy, pay me your attention, focus. Let's start. Bismillah. Today's lesson is talking about weathering. We will take 2 kinds of weathering, as you see here in the screen, which is chemical and physical weathering. Let me say some information about Earth's surface first, after explanation, and go deep inside our today's lesson. Earth's surface contains many layers. One of these layers is named or called crust. Again, crust. What is the crust? Crust is the layer of rocks in the outer surface of the earth. So crust, we live above the crust because the crust is the outer surface of the earth. After that, we need to know more about landform. What is a landform? Landform is a natural land feature on Earth's surface. What is this? I can't understand. So I'll give you an examples to be easy to understand the landform meaning. Landforms may be mountains, hills, plains, plateaus, valley, and canyons. So it's easy now to understand what the landform means. So landform means natural land feature on Earth's surface. After that, the last point here in the beginning of our today's lesson, maps. It's very important for me and you also to know about maps. You have to know about maps, and the definition of maps is maps are useful tools to help to learn more about the world and to locate different features on the land and underwater. Oh, I hear somebody say, "Hey, Mr. Muhammad, it's very difficult lesson. I can't understand anything." No, my friend, the lesson is very easy, but we just warm you up by this information first. It's important to know about maps because without maps, we can't go anywhere because maps help pilot, help shipperman, help anybody to know or to locate different features on land and underwater. So maps is very important. It's easy, isn't it? Okay, turning to topographic map. What is topographic map? In the previous slide, I gave you the definition of map, and we said map is a tool to locate different feature on land or underwater. So specific kind of maps, there are many kinds of maps. One of them topographic. So topographic map is a special kind of maps it shows us the elevations or the heights of the surface features shown on it. So scientists use topographic map to know the location or the elevation of the features on the Earth's surface. Topographic maps use contour lines to show how elevation change. What are contour lines? So, contour lines show the shape of the land by connecting points of equal elevations. Here is the meaning of elevation is the synonym word is height. So we need to know the heights of the features above the Earth's surface, like mountains, like hills, like plateaus, like valleys. Any feature above the Earth's surface, we need to know and to locate the feature above the Earth's surface using topographic map. So topographic map helps us to locate any feature and know the elevation of the Earth's the surface on the surface of the Earth related to features shown on it. After that, we have to know how to read the topographic map. If I have topographic map, how can I read the topographic map? I need to know some rules first. The first rule is the circles. After we finish explanation, by the way, I'll show you a topographic map to be easy to understand and to imagine what we're gonna talk about. So circles on the topographic maps of the control lines show a hill or mountain. So you here have to know what is the function of circles on the topographic map. So circles show us a hill or a mountain. So circle is a sign that tell us about mountain or hill on the topographic map. It represents hill or mountain on the topographic map as well. Another rule I need to know to use a topographic map and to read it, by the way, the innermost circle. The innermost circle here represent the top of the hill. So if I see on the topographic map innermost circle, so that I can understand that it seems to be at top of the hill. Another rule I need to know to read a topographic map is the V-shaped. If I see a V-shaped of control lines, that's mean a valley. So V-shape represents a valley on the topographic map as well. Another rule I have to know to read a topographic map is if I see a contour lines close together, so this represents rapid change in the elevations. We will deal with each information when we go deep inside our lesson, but I need you first to know this simple information about topographic map, which is related to our lesson. So chapter 6, all of chapter 6 is Earth's patterns. So we are about the science of the Earth. So we need to know more about the Earth, and it will be easy to understand our lesson because our lesson is related to these points as well. If I see control lines are far apart, this represents gradual change in elevations. Here I will show you an example of a topographic map. This is a topographic map which we talk about. So you can here see the contour lines. These lines, all of these lines represents contour lines. So you may see here some circles, some lines close together, some lines far apart. So this represents all of what we talked about in the previous slide. Turning to warming up video about our today's lesson, which is weathering. I need you to watch this carefully and come back again to continue our explanation about the lesson.
The outer surface of Earth is a layer of rock called the crust. The crust covers all of Earth. Earth's surface has many natural features, or landforms. Landforms can be different sizes and shapes, but they're all constantly changing. Some landforms take shape quickly, while others form over a long time. One way that landforms change is by weathering. Weathering is the process of rocks slowly breaking down into small pieces. During chemical weathering, chemicals such as those in acid rain combine with rock to form a new chemical. The new chemical washes away, causing the rock to break down. Physical weathering can be caused by flowing water, ice, wind, or temperature changes. Each can cause weathering to a rock's surface. Erosion is the process where weathered bits of rock are carried away by gravity, wind, water, and ice. As some parts of Earth's surface are broken down, other parts are built up. Deposition occurs when bits of weathered rock are carried away and dropped somewhere else to form new landforms. Technology has improved how scientists can study erosion and deposition. Scientists use their data to learn how rock continues to move and how an area might be affected. Got it? Sure you do.
So in this video, we took overview about the lesson in general. So we are going to explore more about weathering and its kind as well. So in the beginning, we need to know the definition of weathering. What is weathering? Weathering is the process in which the rocks in Earth's crust are slowly broken into smaller pieces. So, by another definition, we can say about weathering is the wear away or change in the appearance or texture of something by long exposure to the air. So in weathering, the big rocks will be broken into smaller pieces when they exposed to the air. Water, ice, temperature changes, wind, chemicals, and living things can all cause changes. So the factors that causes weathering are water, ice, temperature, wind, chemicals, and finally living things. What are the types of weathering? Weathering, in fact, have many types, but here we will study two kinds only, which are physical, or sometimes we call it mechanical weathering. The second type is chemical weathering. So we will deal with each kind separately and explain about each kind more and more. So starting by physical weathering, I want you to watch this video in the beginning to know more about physical weathering. Then we will take the wrap-up sheet about the weathering in its first kind, which is physical weathering. So enjoy watching, then come again to learn and explore more about physical weathering.
Physical weathering is the actual breaking down of rock by the action of natural forces, such as water, wind, plants, and animals. But how do these forces wear down rock? Here we see trees growing out of what appears to be a solid granite rock. Actually, their roots are penetrating tiny cracks in the rock. As the trees continue to grow, their roots will further extend and enlarge the cracks, eventually fragmenting the rock, just as these roots have done to this rock. Probably the most common cause of physical weathering is due to the constant freezing and thawing of water in and around the rocks themselves. Let's take a look at a simple experiment which shows how liquid water expands when it turns to solid ice. We fill this plastic measuring cup with water up to the top mark. We want to make sure that we use a plastic container and not a glass container. We'll now take our cup of water and place it in the freezer. Here it will sit undisturbed for several hours. Later, when we view the cup, we find that the water has turned to ice and that it has expanded almost 10%. We note that it has increased in size both upward and outward and has actually cracked the plastic cup. But how does freezing water affect rocks? Water frequently collects on rocks and gets into their small openings. When temperatures drop below freezing, the water in these cracks turns to ice and expands. This exerts a tremendous amount of pressure on the openings in these rocks. As temperatures rise and the ice melts back into its liquid form, it creeps deeper into the fractures. When the water freezes again, it further expands the openings in the rock. This cycle will go on day after day, year after year, until finally a once huge mountainside could disintegrate to a pile of small rock fragments.
So it was an overview about physical weathering. So we now explain what is physical weathering in sufficient information. So you have to know, in physical weathering, rocks are broken into smaller pieces of the same kind. So the original rock will be broken into smaller pieces of the same kind of rock. So there are many factors that affect or cause physical weathering we will deal with, but in the first we have to know the factors such as water and ice and temperature and living things as well. Water is one of causes of the physical weathering. How? By flowing the water can carry particles. The particles are tiny pieces. So particle, you have to know the tiny pieces are particles of rock, soil and sand. These particles scrape here mean scratch off or shaved, okay, against larger rocks. So the particles scrape here mean again scratch off or shave against larger rock. The rocks gradually become smaller and smaller. The force of waves pounding against rocks. The force of wave crunch or pounding against rocks on the shore. It can also cause rock to break down. Another cause of physical weathering is wind. So, wind can carry small particles that can weather the rocks as well. Another force that cause physical weathering, like you watched the video, ice. Ice can also cause physical weathering. The water can seep or ooze or flow or drain into cracks in rocks. If this water freezes, it forms ice. Ice in a rock takes up more space than the water does, so the ice can make the cracks in the rock deeper. The rock may eventually split it or divide it into smaller parts. Temperature also temper, temperature also changes a rock surface by heating. When the surface of a rock gets hotter, it expands or grows larger. When it gets colder, the surface contracts or gets smaller. So scientists think that many temperature changes can weaken the surface of the rock. The last thing that causes weathering, which is physical weathering, is living thing. We will take an example of a living thing is plants. Plants cause weathering as it sprouts. Sprouts here germinate or grow in between the rocks. So this causes cracks in the rocks. The second type here of weathering is chemical weathering. So, as usual, we have to watch this video. So in this video, we are going to explore what is chemical weathering. So let's start and watch carefully.
The second kind of weathering is called chemical weathering. Chemical weathering causes changes in the rocks from the reaction of different chemicals on the surface of the rocks. One common example of chemical weathering is called oxidation. If we were to leave an iron nail in a cup of water for a few weeks, a chemical change takes place. The nail gradually becomes coated with a dark red substance we call rust. Rust is oxidized iron. Here we see the difference between a shiny new nail and an oxidized nail. This rusting or oxidation deteriorates any surface on which it reacts and will eventually cause it to break down and fall apart. The mineral iron is present in many different kinds of rocks, and oxidation can break down these rocks if they're exposed to water for long periods of time. But are there other ways in which rocks can chemically weather? These rocks are covered with a plant called lichen. They illustrate another example of how the chemical weathering process takes place. The lichen actually secrete a mild acid which can dissolve or eat away the surface of the rock. Carbonic acid, a mild corrosive agent, can form when water and carbon dioxide combine naturally in the air or below the earth. Underground caverns like this are one of the most spectacular examples of the effects of weathering caused by carbonic acid. This cavern started out as small openings below the Earth's surface where water seeped in. The water combined with carbon dioxide from decaying plant material in the soil to form carbonic acid. As this acid dissolved the rock around it, the pockets gradually grew in size. The force of gravity, combined with underground streams, carried the dissolved rock fragments away until finally a huge cavern was formed. This, along with the continuous seeping water, caused the cavern formations to grow even stranger as time passed.
Well, so it's clear now to know more about chemical weathering as the last part of our today's lesson. Here is the wrap-up sheet of chemical weathering. It contains the important points of our part, which is chemical weathering. So I need here you to know that chemicals cause rocks to change into different materials and break down. So unlike physical weathering, chemical weathering, the rocks change into different materials, not the same kind like in physical weathering. So during the chemical weathering, chemicals cause rocks to change into different materials and break down. Here, for example, when the rainwater mixes with carbon dioxide, you know that carbon dioxide is one kind of the air gases. So carbon dioxide is a gas. When it mixes with rainwater, it gives us weak acid. The weak acid is a chemical component. You will study chemistry when you become at grade 8, I think. So you have to know this little information right now, which is weak acid. Weak acid is a chemical component which come from the mixing of rainwater and carbon dioxide. So the acid combines with the rock material to form a new chemical. This new chemical breaks down the rock. So all I need you to know here is when we mix carbon dioxide with water, it gives us weak acid. This weak acid combine with the rock material and give a new chemical. This new chemical makes the rocks break down. Another cause for the chemical weathering is animals and plants. When animal and plants give off chemicals or release chemicals, that cause weathering as well. The third point here and the last in our today's lesson is water and warm temperature. Water and warm temperature also can cause chemical weathering. It's important to know that water and warmer temperature are important for chemical weathering. That's why warmer areas or areas with more rain have more chemical weathering than drier or colder areas. That's the end of our today's lesson. I hope that you understand each part of our lesson. Study well, do your best, and the exam will be easy. See you again in the next part, inshallah, tomorrow. Bye bye.